Today, we journey to one of the most remote and wild places on Earth, Russia's Kamchatka Peninsula, home to the recently awakened Krasheninnikov volcano. On August 3, 2025, this massive mountain erupted for the first time in over 600 years, sending a towering column of ash nearly 20,000 feet into the sky. Located within the pristine Kronitsky Nature Reserve on Kamchatka's eastern coast, this complex volcano stands 5,958 feet tall and consists of two overlapping stratovolcanoes nestled within a large ancient caldera. The eruption occurred just days after a massive 8.8 magnitude earthquake struck off the peninsula's coast, one of the most powerful earthquakes ever recorded and the world's largest since 2011. This incredible volcanic awakening has captured the attention of scientists worldwide, as it represents a rare glimpse into the dynamic geological forces that shape our planet. The Krasheninnikov volcano is named after explorer Stepan Krasheninnikov, an 18th-century Russian naturalist who gave the first comprehensive scientific description of the Kamchatka Peninsula. Born in Moscow in 1711, Krasheninnikov spent 10 years exploring this remote wilderness as part of the Second Kamchatka expedition from 1733 to 1742. During his time on the peninsula, he meticulously documented the region's geography, volcanoes, hot springs, flora, fauna, and the customs of indigenous peoples, creating the foundational work, Description of the Land of Kamchatka, published in 1755. The volcanic complex that bears his name sits within a region he would have recognized as one of the most geologically active places on the planet, though he could never have imagined the scale of what scientists would witness centuries later. The story of Krasheninnikov's recent eruption begins not with the volcano itself, but with the earth beneath it. On July 29, 2025, the ocean floor off Kamchatka's coast suddenly shifted with tremendous force. The resulting earthquake measured 8.8 on the Richter scale, making it one of the strongest quakes in recorded history. The tremor sent shock waves rippling through the Earth's crust, and tsunami warnings rang out across the Pacific Ocean from Japan to Hawaii to the west coast of the United States. But something else was stirring deep underground. The earthquake's massive energy didn't just create ocean waves. It may have provided the final push needed to wake a sleeping giant. Scientists believe there's a direct connection between the earthquake and the volcanic eruption that followed. Alexei Ozerov, director of the Institute of Volcanology and Seismology, explained that the earthquake activated magmatic centers and pumped additional energy into them. For centuries, molten rock had been slowly accumulating in underground chambers beneath Krasheninnikov. The volcano had been completely quiet since around 1550. During the time of Ivan the Terrible's reign in Russia. That's about 475 years of silence, long enough for entire civilizations to rise and fall, for the age of exploration to give way to the Industrial Revolution, and for humanity to reach the space age. Yet all this time, magma continued to gather and pressure continued to build in the depths below. To understand what makes Krasheninnikov so remarkable, we need to look at where it sits. The Kamchatka Peninsula juts out from Russia's far eastern coast like a massive finger pointing south toward Japan. This remote wilderness is known as the Land of Fire and Ice, and it's one of the most volcanically active places on our planet. The peninsula is home to about 300 volcanoes, with 29 currently considered active. The reason for all this volcanic activity lies in the movement of massive pieces of the Earth's outer shell called tectonic plates. Kamchatka sits along the Pacific Ring of Fire, a horseshoe-shaped zone of frequent earthquakes and volcanic eruptions that encircles the Pacific Ocean. Here, the Pacific Plate slowly slides beneath the North American Plate in a process called subduction. As the oceanic plate descends into the Earth's hot interior, it melts and creates magma that eventually finds its way to the surface through volcanoes. Krasheninnikov itself is actually two volcanoes in one. What scientists call a complex volcano made up of two overlapping stratovolcanoes within a large caldera that formed about 30,000 years ago. Think of it as a giant bowl carved out by a massive ancient eruption, with two newer volcanic cones built up inside it over thousands of years. The southern cone is older, having developed over a 4,500-year period beginning about 11,000 years ago. The northern cone started forming after the southern cone was mostly complete, with most of its growth happening between 2,200 and 2,400 years ago. Both cones are topped by craters about 800 meters wide, roughly the size of 8 city blocks placed in a circle. The man whose name graces this volcano lived in a very different world from ours. Stepan Petrovich Krasheninnikov was born in Moscow on November 11, 1711, into a soldier's family. Russia at this time was undergoing dramatic changes under Tsar Peter the Great, who was transforming the country into a modern European power. Young Stepan received his education at the Slavic Greek Latin Academy of Moscow from 1724 to 1732, where he was classmates with the famous scientist Mikhail Lomonosov. In 1733, at just 22 years old, Krasheninnikov was selected as one of 12 students to join the Second Kamchatka Expedition, also known as the Great Northern Expedition. This was one of the most ambitious scientific expeditions of any age, with 6 major goals: to explore and map Siberia, establish whether Asia and America were separated by water, explore Kamchatka, chart all waters between Kamchatka, America and Japan, map the entire Arctic coast from the White Sea to the mouth of the Kamchatka River, and explore the northwest coast of America. What started as a student assignment became the defining work of Krasheninnikov's life. From 1737 to 1741, he traveled extensively throughout Kamchatka, studying everything from hot springs and wildlife to the region's indigenous peoples. He described the peninsula's 4 eastern peninsulas, Shipunsky, Kronitsky, Kamchatka and Ozernoye, along with the bays they formed, including Avarcha Bay. He followed rivers, characterized lakes including Kronitskoye Lake, and explored nearly all of Kamchatka's highest volcanoes. In spring 1738, Krasheninnikov made a remarkable discovery in the Paujetki Valley. He found and described geysers for the first time in scientific literature. These natural hot water fountains shooting steam and boiling water into the air amazed him, and his detailed descriptions helped the world understand these geological wonders. But Krasheninnikov's work went far beyond geology and geography. He gathered extensive ethnographic materials about the indigenous peoples of Kamchatka, the Itelmens, Koryaks, and Ainu. He documented their history, customs, religious beliefs, and mythology, providing the world's first comprehensive scientific record of these cultures. He even compiled dictionaries of their languages, preserving linguistic knowledge that might otherwise have been lost. When Krasheninnikov returned to St. Petersburg in 1743, he spent years organizing and analyzing all the material he had gathered. In 1745, he defended his doctoral thesis and was appointed to the Russian Academy of Sciences, one of only 26 Russians to become Academy members in the entire 18th century. His masterwork, Description of the Land of Kamchatka, was published in 1755, the same year he died at the young age of 44. Now, let's return to that historic morning when centuries of silence finally ended. At 2:50 local time on August 3, 2025, 4:50 p.m. Coordinated Universal Time on August 2, Krasheninnikov Volcano began its first eruption in modern recorded history. Staff at the Kronitsky Nature Reserve were among the first to notice something was happening. The initial signs were subtle. Wisps of steam and gas began escaping from cracks on the volcano's slopes. But within hours, the mountain was making its presence known in a spectacular way. A massive column of ash and volcanic debris shot nearly 6 kilometers into the sky. That's about 19,700 feet, high enough that commercial airliners would have to change course to avoid it. Olga Jurina, head of the Kamchatka Volcanic Eruption Response Team, described seeing a lava dome forming on the slope, with strong steam gas emissions and a steady ash plume rising from the northern crater. The sight must have been both beautiful and intimidating, a reminder of the incredible forces that lie just beneath our feet. The timing of the eruption fascinated scientists. Located less than 150 miles from the epicenter of the massive earthquake just days earlier, Krasheninnikov seemed to have responded to the seismic disturbance. While volcanoes don't always erupt immediately after earthquakes, the connection in this case appears strong. According to the US Geological Survey, large earthquakes can potentially trigger volcanic eruptions, but only if the volcano already has enough eruptible magma and significant pressure where the magma is stored. The earthquake essentially acted like shaking a soda bottle. If there's already pressure built up inside, the shaking can cause everything to overflow. Within about 9.5 hours of the eruption's start, aviation authorities issued a red alert, warning aircraft about the significant ash emissions. The ash cloud drifted eastward toward the Pacific Ocean, away from populated areas. This was fortunate, as volcanic ash can be extremely dangerous to aircraft engines and can cause them to fail. Krasheninnikov wasn't the only volcano responding to the massive earthquake. The eruption followed volcanic activity at Klyuchevskoye, the most active volcano on the Kamchatka Peninsula and the largest active volcano in the Northern Hemisphere. Klyuchevskoye had been showing signs of unrest for weeks before the earthquake, with scientists observing lava filling its crater beginning in April and confirming large amounts of fresh lava on July 19. When the earthquake struck, Klyuchevskoye's activity intensified dramatically. The volcano began spewing ash and lava with renewed vigor, as if the seismic energy had supercharged its already active magma system. This created what some scientists called a parade of volcanic eruptions across the peninsula. The earthquake also had other dramatic effects on the landscape. The southern part of the Kamchatka Peninsula actually shifted southeastward as a result of the quake, with the greatest movement reaching almost 2 meters in some areas. This kind of ground displacement is comparable to what happened during the devastating 2011 earthquake and tsunami in Japan. To really understand what happened at Krasheninnikov, we need to think about the incredible geological story playing out beneath our feet. The volcano sits within a caldera, a large circular depression formed by a massive volcanic eruption about 30,000 years ago. That ancient eruption was enormous, depositing about 13 cubic kilometers of volcanic material up to 200 kilometers away. To put that in perspective, that's enough material to bury the entire city of Manhattan under more than 400 feet of volcanic debris. Within this ancient caldera, 2 new volcanic cones gradually built up over thousands of years. Young lava flows from both summit and flank vents descended into the caldera and down its outer slopes, creating the complex volcanic landscape we see today. The entire complex sits along a northeast-southwest trending fissure that has also produced zones of smaller cinder cones extending 15 to 20 kilometers beyond the main caldera. The magma that erupted from Krasheninnikov on August 3 had been slowly accumulating in underground chambers for centuries. The last time lava flowed from this volcano was around 1463, during the final years of the Byzantine Empire. For over 560 years, magma had been slowly rising from deep within the earth, cooling and solidifying in underground chambers, building pressure as more molten rock arrived from below. The earthquake provided the trigger that finally released this pent-up energy. Seismic waves traveling through the ground can cause changes in the pressure and stress around magma chambers. As earthquake expert Harold Tobin from the University of Washington explained, the seismic disturbance may have caused dissolved gases in the magma to come out of solution, like opening a shaken bottle of champagne, increasing pressure and potentially leading to an eruption. The Krasheninnikov volcano sits within the Krasheninnikov Nature Reserve, surrounded largely by wilderness with no immediate threat to people or infrastructure. This isolation is both a blessing and a challenge for scientists studying the eruption. On one hand, there's no immediate danger to human lives or property. On the other hand, the remote location makes it difficult to study the volcano up close. Vsevolod Yakovlev, director of the Krasheninnikov Nature Reserve, noted that while the eruption is certainly a vivid and interesting event, especially for scientists, it's not something out of the ordinary for a region with high volcanic activity. This matter-of-fact attitude reflects the reality of life on Kamchatka, where volcanic eruptions are simply part of the natural rhythm of the landscape. The peninsula was recognized in 1996 as a UNESCO World Heritage Site specifically for its high density of active volcanoes. This recognition highlights the global importance of Kamchatka's volcanic landscape, not just as a geological wonder, but as a living laboratory for understanding how volcanoes work and how they affect our planet's climate and ecosystems. The wildlife in the region has evolved alongside this volcanic activity. Brown bears, the largest land predators in this part of the world, roam the volcanic slopes, feeding on salmon that swim up rivers warmed by geothermal activity. Steller's sea eagles, some of the largest eagles in the world, nest along the coastlines where volcanic activity creates unique habitats. The entire ecosystem is intimately connected to the geological processes that created and continue to shape this landscape. The eruption of Krasheninnikov represents far more than just a spectacular natural display. For volcanologists, scientists who study volcanoes, this eruption provides a rare opportunity to observe and document the awakening of a long-dormant volcano. Such events are relatively uncommon, making each one a valuable piece of the puzzle in understanding volcanic behavior. The connection between the massive earthquake and the subsequent volcanic eruptions across Kamchatka offers insights into how seismic activity and volcanism interact. While scientists have long known that earthquakes and volcanoes are related, both result from the movement of tectonic plates, the specific mechanisms by which earthquakes can trigger volcanic eruptions are still being studied and debated. The ash and gases released by the eruption also have implications beyond the immediate region. Volcanic eruptions can affect global climate patterns by injecting sulfur compounds and ash particles into the atmosphere. While Krasheninikov's eruption appears to be moderate in scale compared to some historic eruptions, any addition of volcanic material to the atmosphere can have subtle effects on weather patterns and air quality across wide areas. The eruption also serves as a reminder of the dynamic nature of our planet. While we often think of the Earth as stable and unchanging during our human lifespans, geological processes continue to reshape the landscape on timescales that dwarf human history. Mountains rise and fall, continents drift, and volcanoes awaken from centuries-long slumbers, all as part of the ongoing story of our planet's evolution. Today's scientists have tools that Stepan Krasheninnikov could never have imagined when he first explored this region nearly 3 centuries ago. Satellite imagery allows researchers to monitor volcanic activity from space, detecting subtle changes in ground temperature and gas emissions that might signal an impending eruption. Seismic monitoring networks can detect earthquakes and track magma movement beneath volcanoes in real time. Aviation authorities quickly responded to the eruption with orange and red alert codes, warning aircraft about potential ash hazards. This rapid response system helps protect the many flights that cross the North Pacific region daily, connecting Asia with North America. Volcanic ash can cause jet engines to fail, making early warning systems crucial for aviation safety. Despite all our modern technology, volcanic eruptions still retain their ability to surprise us. The exact timing and intensity of eruptions remain difficult to predict with precision, and each volcano has its own personality and patterns of behavior. Krasheninnikov's 475-year silence followed by sudden awakening reminds us that geological time operates on scales very different from human time. The indigenous peoples of Kamchatka had their own understanding of these volcanic landscapes long before European explorers arrived. Their stories and legends often incorporated volcanic activity, seeing the mountains as living entities with their own moods and behaviors. While their explanations differed from modern scientific understanding, their observations of patterns and changes in volcanic activity were often remarkably accurate. As of early August 2025, scientists continue to monitor Krasheninnikov's activity closely. Initial reports suggest that the eruption has stabilized into a steady pattern of ash emission and steam release, though volcanic eruptions can be unpredictable and the situation could change at any time. The eruption has generated intense interest among researchers worldwide, many of whom are eager to study this rare awakening of a long-dormant volcano. The data collected from this eruption will contribute to our understanding of volcanic processes and may help improve our ability to predict future eruptions at similar volcanoes around the world. For the people of Kamchatka, this eruption is part of living in one of the most geologically active places on Earth. The peninsula's residents have learned to coexist with volcanic activity, understanding both its dangers and its benefits. Volcanic soils are often highly fertile, and geothermal energy provides heating for communities across the region. The eruption also highlights the importance of preserving wilderness areas like the Krasheninnikov Nature Reserve. These protected landscapes serve not only as habitat for wildlife but also as natural laboratories where scientists can study geological processes without the complications of human development. The reserve's isolation, which makes scientific study more challenging, also ensures that volcanic processes can unfold without immediate human interference. As we continue to monitor Krasheninnikov's activity, we're reminded that our planet remains a dynamic, changing system. The same geological forces that created the spectacular landscape Stepan Krasheninnikov explored in the 1700s continue to shape the Earth today. While we've gained tremendous scientific understanding since his time, volcanoes like Krasheninnikov continue to teach us new things about the incredible forces operating beneath our feet. The awakening of this ancient volcano connects us to the deep history of our planet, reminding us that we're part of a much larger and longer story than our individual human lives. In the towering ash column rising from Krasheninnikov's crater, we see both the incredible power of geological forces and the ongoing evolution of the Earth itself, a process that will continue long after our current civilization has become history, just as it continued through all the centuries when this mighty volcano lay sleeping, gathering its strength for this moment of spectacular awakening. Thanks for watching, like and subscribe and don't forget to explore more geological wonders on our channel.